All right, everybody, let's get her done. This is the last lesson for Chapter 5. This is 5.4, the last lesson. I think that the notes you have say 5.4b at the top. Mine say 5.4a. I'm sorry, mine has a, just fix it here so it matches yours. All right, and we're just gonna get this lesson done. All right, what we're going to talk today about is making sure you understand the difference between two kinds of area, net area and total area. And this is really the difference between having the stuff that's above the x-axis and the stuff that's below the x-axis. All right, when you do net area, you just add up the positive and negative area together. It's just simple addition. Positive area is, of course, above the x-axis. Negative area is below the x-axis. This is what you've been doing all along. When you are specifically asked for total area, the total area puts an absolute value around anything that's negative. And so it is going to make the negative area a positive number so that everything you add is positive, which is going to give you a bigger number than what you had before. So you leave the positive area alone, but you take the negative area and you make it positive with an absolute value and then add that up. So the net area will always be less than or equal to the total area. The total area is going to be the larger. Net will either be equal to or smaller than the total. So if you're thinking about a visual, taking the drawing that I've made, anything that is below the x-axis, when you make it an absolute value, it becomes above the x-axis. And so then you're going to have little pieces that are made positive by the absolute value, and then you add it up. So everything is positive. That's what total means. So how do you do that? How do you find this area, the total area, analytically? And analytically always means without a calculator. All right, so the way you find the total area between the graph and the x-axis, whoops, this is a D, A to D, I'm sorry. All right, fix it on the graph too. That should be a D. All right, so this is the way you're going to do it. You partition means to break something up with the zeros. So let's take a look at this graph, and the zeros are where it crosses the x-axis. So we have a 0 right here. We'll call that 0b. And then we have a 0 right here, and we'll call that 0c. So we have A, then B, C, then D. So D is the last one. So you want to partition your areas by their integral. Then you're going to integrate over each of those integrals. So we're going to set up an integral that would go from a to b of parentheses f of x dx, and it will be positive because it's above the x-axis. And then we will do the integral from b to c from f of x dx, and that will be negative. And then we will do from c to d of f of x, and that will be positive again. And then we need to add the absolute values. So the one that needs the absolute value is this negative one. And so then that would make it positive. And then you add them all up. So you'll have positive plus the positive, and then you'll have your total when you add up all the values together. So that's the strategy. Start with the zeros, break up each integral piece, and then the pieces that are negative, you need to put absolute values on to make them be positive. So let's try it. Let's see. Oops, that must have been a duplicate. Let's go to the next one. So compare the net area and the total area between the function the parabola and the x-axis on 0 to 6. Okay, net. Net area is simply the straight integral from 0 to 6 of 4 minus x squared dx. I don't have to partition that. I don't have to break it up. That's what net means. And so we'll do our brackets to show that we're doing an antiderivative. We'll do 4x as our antiderivative, minus x cubed over 3, plus c, don't forget the plus c, from 0 to 6. Okay, so just notice my notation. I wrote an integral, so make sure you remember that. Make sure you remember the dx at the end. Make sure you remember the brackets and the plus c. Those are the things I'm noticing that some of you are forgetting. Okay, then we'll evaluate this. And so we'll have 4 times 6 minus 6 cubed over 3 plus c minus, and then 4 times 0, 0 cubed over 3 plus c. So altogether, that's going to turn out to be 24 minus 216 over 3. And so we'll do a math fraction on that, which will give me negative 48. All right, and that answer came out to be negative, and that's fine. For the total area, we have to partition it. And we can't partition it unless we know what the picture looks like. So we have a parabola that comes down like this. It crosses the x-axis here at 2. So we have from 0 to 2 out to 6, which goes off our screen. And so we have this partitioned now into positive area and negative area, which is going down off the screen. So if I'm going to find out the total, I have to break this up. I have to go from 0 to 2 of 4 minus x squared dx. And I also need to go from 2 to 6 of 4 minus x squared dx. Now this part is going to turn out to be positive, and the second one is going to turn out to be negative, which I will need to put absolute values around that part. All right, so my antiderivative bracket, 4x minus x cubed over 3 plus c from 0 to 2. And then I also am going to have 4x minus x cubed over 3 plus c from 2 to 6. Okay, the first part, when I plug in my values for 2, I'm going to get 4 times 2 minus 2 cubed over 3. And then I get the 0 plugged in, so that's nothing. Okay, and that turns out to be, if you do the math fraction on that, 16/3. The second half of it, when we plug in, we're going to get 4 times 6 minus 6 cubed over 3 minus 4 times 2 plus, when I distribute, 2/3 over 3. All right, and then for that one, I'll do a math fraction on that. Let's see what I get here. Negative 160 over 3. All right, for that negative one, I have to put the absolute value around it. And then I'm going to add these together. So 16/3 and the absolute value of negative 160/3. And so I'm going to get a total of positive 176 over 3. So I get a positive number because I used the absolute value. So that's the total. So then look at compare the two answers, right? Your net area, which is negative 48, is less than or equal to your total positive area. So that should always be the case. All right, now let's do how to find the total area numerically. And numerically means with our calculator. So if you don't have your calculator yet, please grab it and make sure it's in radian mode so that we can move forward with this. To do it with the calculator, you're going to use the absolute value first. So to find the total area between the function and the x-axis on the interval 0 to 7, notice it says total. Okay, total area. So you have to write, even though you have your calculator, you have to write it down, 0 to 7. The absolute value goes inside the integral. So the f of x. Well, what is f of x? F of x is x times sine of x plus 1 into your absolute value, and then do dx. All right, so you need to write down this integral first, and then we'll use our calculator to find that. So please pause the recording, try typing that into your calculator, and then let's compare answers. All right, so verify that I'm in radian mode, and then I'm going to do math 9, and I'm going to go from 0 to 7. Whoops, that was 1. 0 to 7. And then I want to put my absolute value symbols in there. So if you remember, those are under math also, but they're not. They're over one menu. They're over to the number menu. So you're going to go over to that, and the absolute value is your first choice. And then I'm going to put in x, and then the sine of x plus 1. And that will put those in the absolute value for me. And I'll go over to my dx, and then I'll hit enter, and I will evaluate that. So this is going to give me the total area. It's thinking about it a little bit, doesn't quite. There we go, 16.016. Okay. Okay, if we had needed to do net area, we would have done the exact same thing, but we would have left off the absolute value. So you would have just used parentheses instead, and that would give you a number that is less than or equal to the total area. Okay, usually less than, because we have some, the net area has negatives, and the total area only has everything positive. Okay, so what if you have more than one function at a time? So let's get a look at how this might go. So we have sine of x plus 1, and the sine of x plus 1 looks like this. Oops. Okay, it comes up, touches the x-axis. Okay, there's your sine of x plus 1. And then the equation 2 minus x. And 2 minus x is going to come down looking like this. We want to find the total area between the function sine of x plus 1, that's this part, and then turning, and then going along 2 minus sine x, and the x-axis, and the y-axis. That's this region right here. And we're going on the bounds of 0 to 2. But we have to partition this again. All right, we need to partition this at this point right here we got to determine what that is using an intersection feature. All right, so go ahead, pause the recording again, and then come back after you have found the intersection. Okay, so hopefully you did an intersection and you got 0.511. All right, now at this point, right after you found the intersection, I need to teach you how to store this in your calculator's memory. Okay, so you've just done it. It says intersection on your screen. Okay, now we want to go to the store feature. So down on your calculator, it's right above the on button, so you want to hit store. All right, so what I'm going to do is quit this, so second quit, so that I'm at a clear home screen, and hit store, and you should show up with something like that. So it's going to take the last answer that you just had, and it's going to store it, and we want to tell it to store it in a random variable. I'm going to pick variable letter A. So A is right above your math key, but it's an alpha, so I have to hit alpha first and then hit A. So I'm going to hit alpha A, and then it says A right there, and then I'm going to hit enter, and it just took 0.511, and it's going to store all those accurate decimals in my calculator for me. All right, so that's what you should do next. Then on your drawing for me, you should label, okay, it's not a question mark anymore. I've decided to call this A, and A represents 0.511. Now the calculator has more accuracy than that. That's so that you want the most accurate value possible. All right, now we're going to write our integral to find the total area. So we are going to partition from 0 to A, and 0 to A is following the curve of the sine function, so sine of x plus 1 dx. And then we're going to do the second partition, which is picking up at A and going the rest of the way to 2, and now we've turned, and now we're going to use 2 minus x quantity dx. I don't need absolute values because all of these are above the x-axis. And now I can let my calculator do this all for me with the A value that I've stored in my calculator. Okay, so I've got that A value stored, so I'm going to do a math 9, and I'm going to go from 0 to, and I'm going to put alpha A in there because the calculator will remember what alpha A is. And then I'm going to put sine of x plus 1 in that first equation and hit dx. Then I'm not going to hit enter. I'm going to do plus, and I'm going to do a second math 9. And this time I'm going to start at alpha A, and then I'm going to finish at 2. And I'm going to put the function in for that of 2 minus x. And then that will go to the x-axis. So your calculator can do both of them at the same time. Now I expect a positive answer because all of my values were above the x-axis. So I'm going to hit enter, and I get 1.747. Now I just want to show you the same thing. What if you hadn't stored alpha A? Okay, what if you just you rounded and you did 0.511? Let's try that a minute. So what if I used, instead of A, I used 0.511. And then in the other spot where I'd used A, up there, let's see if I can get up there. No. Okay, 0.511. Okay, suppose I'd done that. Let's compare the answer. All right, so there is a slight difference in this one out far at the far decimal place. You see that it's different, that it ends in a 5 and the other one ends in a 6. Okay, so this one, we call that negligible. There was hardly any difference. But there will be others where there will be more significant difference. So it's always best to store your value as a variable in your calculator to guarantee the most accuracy. All right, so our total area turned out to be 1.747. All right, so here's, I think, our final one today. Use the total area between these functions and use geometry to our advantage. So let's get an idea of what these graphs look like. You know, you could use your calculator if you're not sure. One is going to be a parabola, the 5x minus 2x squared. It'll be an upside down parabola. And then the line y equals 2 is just going to be a straight line, or the function 2. So you can take a look at that. But we want to see what it kind of looks like and where they cross each other. All right, so we've got the parabola. Okay, which comes up and then comes back down. And then we've got 2 here, which comes straight across. Okay, so how do we find the area between these using geometry to our advantage? Okay, well, the way we use geometry is once we've found these corner points here, if we come straight down, then these corner points make a rectangle. So we just want this part of it, so we don't want to go all the way down to the x-axis. We're going to want to subtract the rectangle underneath. Okay, so first we got to find these intersection spots here, and we're going to store them both in our calculator. All right, here's my graph of the parabola and the line y equals 2. So I'm going to do a intersection, number 5, and I'll move to that intersection spot. So the first one is 0.5. Okay, I don't need to store that in my calculator because that was a perfect intersection spot. So I'll just keep that in mind, that that was 0.5, and then let's do the other one and figure out what that one is. So we'll head on over to the other intersection. And that one is 2. All right, so we don't need to store these. We'll keep those in mind from 0.5 and 2. All right, so let's erase those question marks. And we know now that those values are 0.5 and 2. So our integral that we set up is from 0.5 to 2 of 5x minus 2x squared, quantity dx. And I don't need absolute values because it's all above the x-axis. But that integral alone is going to give me all the area down to the x-axis. Okay, so all of that value will be included because I said dx, which meant go all the way down to the x-axis. So I will find this value. So I'll do a quick math 9 on that one. I'll go from 0.5 to 2. Okay. And that gives me 4.125. Okay, now where I'm going to use geometry is I'm going to erase or delete or subtract this rectangular area here. Okay, I would like that all to go away. And that rectangular area has a base of 1.5. Okay, that's 2 minus 0.5, and it has a height of 2. So that rectangle is 1.5 times 2, or 3. And so when I subtract that, that will essentially erase all of this area down here. So we're going to subtract all of that. And then I'll be left with an answer of 1.125 for the total area between those two things. So I was just using geometry as a subtraction of the lower shape. We've done the addition of the lower shape, now we're doing the subtraction of the lower shape. All right, and that finishes chapter 5. So we'll be spending Wednesday, Thursday, and Friday reviewing, and then on Monday you'll be taking your test on all of the ideas of area. So back to, we started with RAM. We did LRAM, RRAM, and MRAM. So that feels like a long time ago. And we did trap, so we did trapezoids. And then we did circles, semicircles, different triangle shapes. Then we moved with geometry, then we moved into Math 9 and the antiderivative. So all of that wrapped up into one.